Alrighty, Chapter 9, Using Classes and Objects. If you've taken a Java course here, I know you have the idea of classes. It's possible you haven't, so we're going to dig deep into them. This is really important stuff. Honestly, it probably should have come a little bit earlier in the book, but be that as it may, we're going to go on. So what is a class? A class is a group. I think this is kind of a lame description of it. I'll probably give you a different one real soon. Dogs, cats, and cows belong to the animal class. Great Danes and Chihuahuas belong to the dog class. That's kind of setting up an inheritance hierarchy here, where you have a base class called animal. Dogs inherits from the animal class, and Great Danes inherits from the dogs class. So, what would I say a class is? And I've said this before in my other classes. A class is a collection of data and the methods that act upon that data. So, can a class not have any data? Yeah, sure. Can a class not have any methods? Yeah, sure. But in general, this is a true statement. A class is comprised of data, which are variables, or objects, because everything in C# is an object, and the methods that act upon that data. Classes are the building blocks of object-oriented programming. Double, int32, float are classes. Any number declared as one of these classes can be used in arithmetic, converted to a string, etc. So types of classes. Classes that are only application programs that have a main method, and classes from which you instantiate objects. You can make a class from which you instantiate an object have a main method, but that's pretty rare. So everything is an object. Every object is a member of a more general class in this language. An object is called the instantiation of a class. The class is the blueprint. The house that you build from it is the object. You can use the same blueprint to build 100 houses. So every class has instance variables, which this textbook also calls fields. Those are the attributes. That's the data that the object contains. Let's start giving real-world examples of this. Like if you have a point object, a geometric point. A point might have an x and a y value. Those x and those y values are attributes. Those are the data components of the class. Or if you have a 3D system, you have an x, y, and a z system. If you're in physics and you want to measure a vector, you probably have an x, y, and z, and then also a, oh gosh, I forget what it's called. The distance, the force that vector is going in, and I just botched that so you physics majors don't yell at me. Anyway, so a person has attributes. I have a name, I have an age, I have a hair color. Those are all attributes. Those could all be instance variables. Every person we meet might have different instance variables. You probably have a different name. You probably have a different age. You probably have a different level of education. Whatever. All of those could be instance variables attached to a person class. So an instance variable is something that holds the components of the class which differ for each object. You can also have variables that apply to every object in a class. But we're going to brush up on that later. For now, all we care about are instance variables that differ on an instance-by-instance basis. John has a different name than Becky. John can have a different height than Becky. John can have a different weight than Becky. John can have a different address and phone number than Becky. So all of those things differ on an instance-by-instance basis. You have a Becky object with all those pieces of information, and you have a John object with all those pieces of information. And, they could be the same. Maybe they're the same age, or height or weight, but they can be different. So the instance variables are also known as fields. Then you have instance methods, where you can manipulate that object. You could set that person's age. You could set that person's name. You could promote them in a company. You could set their salary. You could calculate their paycheck. Or if you have a geometric object that represents, a rectangle with a height and a width, then you could calculate the area of that rectangle. And different rectangles would have different height and widths. So the width and the height would all be instance variables of the rectangle class. And then you have the client class. Different textbook calls that the driver. The client class is the one that instantiates objects of another class. So you write a car class, and then you write an inventory program that keeps track of all the cars that you own. And the client class is the program that uses the car class. That instantiates, that creates 20 different cars and tracks all the information about them. So creating a class from which objects can be instantiated, you have to use the word class. You can say that a class is public, protected, internal, or private. We're going to kind of skip that for now. So here's the simplest class. Class followed by an identifier, a name, with no data and no methods. Woohoo. Would you ever use that? No. But now we're going to give our employee class a piece of data, an instance variable. And this would be about the time that we actually want to pop this open. So I'm going to do File New, create a new console app. Realistically, we should put every class in its own file. For demonstration purposes, I'm going to go ahead and put the sample class that I'm writing here in the same file, in the same namespace. So I'm going to make a class called point, just like I mentioned. Yeah, we know it's got 0 references. Thanks, tool type. And it's going to have a height, an x and a y. Int x, int y. Now I'm going to create some points down in main. Main is the client of the point class. Point p1 is equal to new point. p1.x All right, so I'm going to leave that alone for just a little minute, but we're going to set these values, these x and y values. But to do that from the client class, these need to be marked as public. So I could say x is a public variable and y is a public variable. So now my field definitions, my instance variables say public int x and public int y. Later on, I'm going to tell you to get in the habit of making all your instance variables private. But for now, we're going to make it public. Start off with the easiest example and then grow. Now that we have done that, we can do p1.x is equal to 10, p1.y is equal to 20. We can create a different object. Point p2 is equal to new point. p1.x is equal to 0. p1.y is equal to negative 100. Just different values. They could be the same, but they could be different. Now we have 2 different points. A line segment is defined as 2 different points. So, we could define a line segment with these 2 points. A triangle is defined as 3 points on a Cartesian plane, whatever. So for whatever purpose, we have these x and these y points. Excuse me, these points with different values. Let's do another one called person. And all he's going to have is a name and an age. So, class person. I'm putting this underneath the other class. Public string name, public string age.
We don't have to called public in Java. Do we get those? Or?
Right. The question is, in Java, we didn't have to put the word public there. That's because the default in C# for instance members is different than the default for Java.
What is
The default in Java is very close to being public. It's package. I forget what the actual keyword for it is, which means that anybody in that package can get into the X and the Y variables. The default in C#, I believe, is private. Might be protected. We'll find out real soon. Let's look it up. No, that didn't help. Oh, come on. So the the default in C#, unlike some other languages, is that your instance variables or your instance methods are private, meaning that they could not be changed down here. Maybe we have some secret bit of information that the client is not supposed to be able to access, and really, once we get along, we get going with this, we would make it private. I don't know. Nobody wants anybody to know their weight, so private double weight. This is silly, right? But then when I create a person, I'm not going to be able to set their weight from the client program. Then how would you be able to set it? Well, you'd have to do something. You'd have to provide methods or something that could then go in and modify the weight because they're not accessible to the client code. I'm going to leave that there, but then I'm going to come down here and we're going to demonstrate that to be true. I'm going to make a person. Person Bob is equal to new person. Bob.name is equal to Bob Roberts. Bob.age is equal to 30. Bob.weight, we can't change weight. Why? Because it's declared as private. And private is the default, so I don't even have to stick the word private there if I don't want to. I like to see it, because I've used other languages where the default is public. Nothing wrong with putting it there. I'm going to go ahead and make it public now just so that we can set Bob's weight. Bob's 175. Notice we have these units here. Okay, I made age a string. It should have been an int or double, right? So I'm going to change age to be a double. So a person has 3 attributes, 3 instance variables, 3 fields. Get used to using the term fields. Field is an instance variable. And our point class has 2 instance variables, 2 fields. Every point is described by an X and a Y. Every person contains 3 pieces of useful information that we care about. And here's how we create a new person. Notice the use of the new keyword. You give a data type, you give a variable name, and you say equals new, and then you give the data type, class type again. Oh, and by the way, I'm sure that the book has mentioned this several times, but if you're incredibly lazy and you don't feel like typing person there, you could just use the word auto. No, you can't. Never mind. Quickly abort. Never mind. Alrighty. The auto keyword allows it to pick the type that matches the data that you're assigning to it as you create it. Didn't work there. Not going to talk about it. It's been mentioned in the book more than once. So now we know how to define a class. You use a class keyword. You list your instance members. Now we could add a method. Not sure what method. What could we do with a point that we care about? I don't know, but let's write something called fraction. So class fraction. Fraction has got two pieces of data. Assuming that they are whole values for the denominator, I never can say that right, denominator and the numerator. Public int numerator, public int denominator, and let's write a method that will calculate the result of that. So public double, because if you divide them and they're not an equal integer, right, then you probably get a double. Then calculate, and what does it do? It returns this dot numerator divided by this dot denominator. So, you know, if your fraction is 1 over 3 and you call calculate, you ought to get 0.333. If your fraction is 2 over 4, then when you call it, you ought to get 0.5. Let's do that. Up at the top of main, I'm going to create a fraction. Fraction f1 is equal to new fraction. And wouldn't it be neat if we could do this? My fraction has a numerator of 1 and a denominator of 2. It doesn't support that yet, but when we add constructors, it will. But anyway, so f1 dot numerator, should have just called it top and bottom, is a 1. f1 dot denominator is equal to 3. Let's get the result. Double r is equal to f1 dot calculate, and then when we print r, it should be 0.3333, 1 divided by 3. I'm going to move a curly brace here and a curly brace here just to get it all on the screen at the same time. Same is true of the fraction class. I'm going to move his curly brace up on the same line. Kernighan and Ritchie style, not Block style. Alrighty, so there we go. Let's print out r and make sure that it's good. Console dot write line r fraction equals placeholder 0. Comma r. So hopefully when we run it, it'll say that the r fraction equals 0.333. I did not add a read or read key at the bottom, so when I run it, I'm going to have to run it with start without debugging. Ooh, and r fraction equals 0. That's actually what I was expecting, but I forgot that that was going to happen. And why is that happening?
So because they're ints?
Yep, integer division. If you divide an int by an int, you get the result of an int, so it would be rounded down. What's the easiest way to fix that? Well, we could just make these doubles. Why not have a numerator of 1.3 and a denominator of 7.215? Or we could cast one of these to a double as we divide it. Let's do that. Let's just take the denominator. So in the calculate method, I'm going to convert the denominator to a double. That'll be enough to get the whole thing to be a double. I don't need to convert both of them. An int divided by a double resolves in a double. You just want to avoid the circumstance where you're doing an int divided by an int. So debug, start without debugging. There we go, 0.3 out to 16 places or whatever it's displaying there. All right. So we have written our first class that had both instance members and a method. Instance member, also known as a field. Instance member, known as a field. Instance method. Alright, hope you get all that in. I'm going to scroll up here so you can get the point class of the person class if you didn't. Pause as required. Then to the fraction class. Then to our program itself. There we use the fraction class. There we use the the person class. And there we use the point class. I did something dumb on that one. What did I do dumb on that one?
The point?
Yeah. When you typed it in, what's really dumb about those bottom two sets there that I did?
You mean point 2?
Yeah. Why did I create a second point but then change the values to 0.1? So if you didn't catch that while I was typing it, go ahead and do so now. 0.2 dot x, 0.2 dot y.
I was just going along with 0.2.
Right. Yeah.
Didn't think anything of it.
Made sense to me as I typed it, but it was wrong. Okay, so let's go back, see what they have to say. We have several different class access modifiers. And they're slightly different than Java's. So we have to go ahead and look at them. Well, these are actually for the classes, not for the instance variables themselves. But the instance variables will be pretty much the same. If you want, you can make your class accessible to other classes. See, we wrote several classes here. What if we want the point class? It's so incredibly useful that we want any other class in our solution to be able to use it. We could make it public. What if we only wanted things in this namespace to be able to access it? If that was true, like the person class, we'd make it private. So public means access to that class is not limited. Protected means that access to that class is limited to the class and any classes derived from it. Inheritance. Internal means that access is limited to the assembly to which the class belongs. An assembly is a group of code modules. Alrighty. And then private access is limited to another class to which the class belongs. In other words, a class should be made private if it is contained within another class. And the containing class is the only one that should have access to it. Usually we're going to make our classes public. So we have field access modifiers. We've already used public and private as our field access modifiers. There are other ones. Static, read-only, volatile, new, internal. These are new to your Java programmers. Most class fields are non-static and private because static means that value is shared between all objects of that class. And as a matter of fact, you don't have to have an object at all in order to get access to that member. So you make things non-static, you make them private, and then that piece of data is nice and securely encapsulated in that class, meaning that the only access to it that the client code can get is through members that you provide. And your members can provide validation. You might not want somebody to be able to set a name that's empty, with 0 characters in it. You might not want somebody to be able to set a negative age, that kind of thing. So you can validate your data. We might not want fractions that have a denominator of 0 because when we do our calculation that would be an error. So using private fields is known as information hiding. Typically you make your data private and your methods public. Your methods should be public because your client code probably needs to call the methods. Otherwise you wouldn't write them. On the other hand, you can put private methods in your class, or protected methods in your class. If you're sure that only the class needs to be able to use them, you just got to figure out how you're going to do that. Alrighty, and this PowerPoint is just flying over topics that some books take several chapters to talk about. Composition is the idea of using an object within another object, which defines a has-a relationship. We've already done that to some degree because a string, for example, is a class. So if we look at our code here, a person has a name. Suppose that every person has a location on a map. Every person could have a point, location, right? Like that. We might even want to create a new point as we create the object so that we wouldn't get null. We wouldn't have a null access when we try to get a hold of it. So, this is composition. Every person has a location, which is an XY coordinate. You use that concept when you're figuring out what data your class tracks. You might write a library class that keeps track of books, and so the library would have, books in it. More likely it would have a list of books, But that kind of thing. We will get into better examples as we go. So here is an employee class. They have an ID, a private int called ID number, and they have a welcome message, which is public. So when we create an employee, it's going to have an ID number of 0 because that's the default value that is assigned to integer fields. So when we call the welcome message and it says welcome from employee whatever, it's going to say welcome from employee 0. How can I help you? That's the next thing we would have to do is to provide something that would assign ID number. Something either internal to the class or at least a method that the client could call in order to change that value. So when you declare a class, it does not create any objects. Just because I wrote the person class, there are no person objects out there to use. We're not tracking any data yet. We just have a class. Just like you have a blueprint. You buy a blueprint from an architect. You don't have a house yet. You have to build the house. You have to instantiate the house. You have to create an object from the class. And that's what we did down here when we created our new person. Now we have a person object to play with. So the class is not the object. Sometimes the terminology when you're talking real loosely and real quickly can kind of get confused. But this creates an object, and now Bob is a reference to that object. So when you create an object, you call its constructor. Well, I don't see a constructor. What's a constructor? A constructor is a method. A method that initializes the object. That initializes the object. Now, all classes have a default constructor that is provided for you. That's why we don't see it. But you can also write your own constructors. We might want to write a constructor that sets the ID number so that it won't be 0 for every employee that we make. And if this stuff doesn't make sense to you, if you haven't hit these ideas before, you really need to read this chapter. Don't just look at the PowerPoint and listen to me. Alrighty, so they very nicely mention constructors, but then they don't go into them yet. But we do talk about how you can change the values of private instance variables, of fields. It looks a little bit different than it does in Java. I'll give you all a real quick look at how it's done in Java, and refamiliarize yourself. And you people who don't care about Java, just close your eyes and ignore this. What you do, like if you have a x variable here and it was private, and you wanted to add an accessor, a getter, is you would do something like this: public int get x, right? And then you would put inside here return x. Well, you could do it that way, but C# has a cooler syntax for implementing getters and setters. So if those days are gone in C#, you still can if you want, but here's what we're going to do. We're going to add a get method and a set method for our variables. Sounds the same, but the syntax is quite a bit different. Take a look at this. You add the word get, and you add the word set. Alright guys, so I'm going to type some stuff. Do not type this. This is for you Java people, because the syntax is different enough that I want you to see the before and the after. Here's how you would do it in Java. You would do public int get x like that, and then you would return this dot x. Then you would do, and I'm putting them in comments, public void set x, which accepts an integer and sets this dot x equal to the x parameter. And I put my semicolon in the wrong place here, but since I'm not actually going to be compiling this code because it wouldn't, yeah, I guess it would. Alrighty. And then when you wanted to use that stuff down in your code, you would do something like this: p1.setx to 10. And if you wanted to print it out, you'd say value is equal to p1.getx. That's a little bit clumsy, but for those of y'all who have taken several semesters of Java, you're used to doing it that way. What C# lets you do is to declare your fields in such a way that all you have to do is do p1.x is equal to 10, p1. Value is equal to p1.x, and it calls the getters and the setters automatically. So I think I'm going to delete those, but here's what it looks like. I'm going to go ahead and add a new variable called z, and it's going to be a field with getters and setters. Public int z, but I'm not done there. Now we're going to say, okay, when you call get, what does it do? It returns z. And when you call set, what does it do? It sets z equal to the value that it is being set to. So here's how you would have implemented x properly. Well, if I had put these two comments underneath x like that in Java. Here's how you do it in C#. That way, when you're ready to set the values of that z field, why are you underlining me there? I guess when I went and I added the word private inside the namespace, it complained to me, so I'm going to take that word private out. Hopefully once I rebuild it, that error will go away. Okay. I want to do that more close to my main so that you can see it all in the same place. So right above class program, I'm going to do one more class. I don't even know what I'm going to call it. Square, because this. And let's do a rectangle. Rectangle has two values, but I usually assign rectangles as homework. Too bad. We're going to do rectangles. And a rectangle has a height and a width. So double height, but I'm not done there because I want to provide getters and setters, accessors and mutators. So when get is called, it's going to return the height When set is called, it's going to set height equal to the value that is being set. Now down here in my program, inside main, underneath my curly brace, of course, really bugs me that my curly brace is up there. Rectangle R1 is equal to new rectangle R1.x is equal to 100. Excuse me, it's R1.height. R1.height is equal to 100. R1 dot That's all I set. I haven't created a width variable. And I forgot to make this field public. So public double height, and then I can set it down here. This is the same thing as encapsulating a variable in Java. We have a field now called height, and we have a getter and a setter for it. And we could even prove that we are calling this method when we give it a value. I'm going to expand this set method right here. I'm going to put some extra code in it. Whenever set is called, we're going to console.writeLine setting height to placeholder 0, comma, the height. See if I can possibly get all this back on the same screen again. Like that, okay. Again, if you're getting confused by the curly braces, take careful note. I just moved it next to the class definition into the main definition there. All right, so when this runs, and when it does this, r1.height, we're going to see it say setting height to 100. So just by the act of calling the equal sign here, it's going to call our set method, execute all the code in the set method. And we could do data validation there. If it was illegal to set the height of the rectangle to 0, we could forbid that. I'm going to run it, see if that works. Build, rebuild solution. I'm going to go down and add a read key. They just make me feel better at the bottom. So at the bottom, I'm going to add my usual comments. This is the end of main. That's the end of the primary class. That's the end of the namespace. But anyways, console.read key. It'll just hang out there waiting for us to close it now, right? Okay. That way I can wail on the green arrow to get it to run. Ooh, and it blew up. I did something wrong. I'm going to pause this while I figure it out.
Oh, is one for the, actually the method, or one's for the instance variable, one's for the method?
Right, we need to make a private variable that this is exposing, and it needs to have a different name. So, yes, stop. So I'm going to make a private variable called height with a capital H. No. I put that in the wrong place. Okay, here's the rectangle class, right? Let's create a private variable. And we need to change our getters and our setters. We don't have to change those, but we have to change what they return. So you see what I did here? I just added private double height. Now I'm going to go to the getter, and I'm going to change this to get to return uppercase H. height, and down here in the setter, I'm going to right line uppercase H height, and I'm going to set uppercase H height to the value. So what's going on here is this is our actual data, and this creates a framework for a getter and a setter for that piece of data. Hope that makes sense, and we will provide several more examples of that. For instance, we're going to do a width right now.
My errors didn't go away.
Well, let me make sure my error did go away at that point. It said setting height to 0, which is not what I was hoping to see. Oh, that should still be a lowercase. That should be the word value there. I botched that. Console.WriteLine, setting height to 0, end quote, comma, value, because value is what we are assigning into it, and then height, uppercase H, is equal to value. All right, setting height to 100. Okay, so that does work. Take a look at this. Make sure yours matches exactly with the capital H there, lowercase h there, uppercase H there, uppercase H there. All right, so we could add, a width to a rectangle, but I want us to do all this again. I'm going to do it to the point class or the fraction class, anything that has two pieces of data. Yeah, let's do it to the fraction class. So we have a numerator and we have a denominator. We're going to make those private. Private int numerator, private int denominator. Now when I run it, it's no longer going to work. We broke it because the client code, I'm going to scroll down to it, you don't have to. Well, I mean, you could just click on your error message and you'd find it. Can no longer access numerator and denominator. Those are now private instance variables. It says is inaccessible due to its protection. So we have to make kind of a wrapper field for it. We have to add some getters and setters for it. So I'm going to go back up to the fraction class, and I'm going to declare another one, public int numerator with a capital N, and no semicolon, by the way. I hope that y'all caught that. I should have highlighted that earlier when I was down there typing that. And so we need a getter and we need a setter. So what does get do? Get returns numerator with a lowercase n. It returns this variable right here. Oh, excuse me. Take the s off, returns. And then sets numerator with a lowercase n equal to the value that is being assigned. And if you've done C++ programming and you have the idea of overriding the assignment operator, this is really what this is doing at this point. I'll just say that and I won't mention it again, but you C++ programmers understand that. So let's do the same thing for denominator. We're going to have to provide another get set framework, and it's again going to be a capital D. Public int denominator. So again, get, what does get do? It return denominator, semicolon. It's set, we'll set denominator equal to the assigned value. And that is our fraction class. And now we're going to take advantage of the fact that we have this ability to do this to make it look like we have a value instance variable when we really don't. So if you set the numerator equal to 1 and the denominator equal to 3, its value is 0.333, right? We can declare a getter which would return that value by doing that math. So public int, I'm going to do a capital V value, and get, all it needs to do is return the numerator divided by the value. Now we're not providing a setter. Why? Because you can't change the value that way. You can only change the value by modifying the numerator and the denominator. I see some error lurking down here. I wonder what that is. I'm going to rebuild and find out. Good, it went away. No, it didn't.
Down at the bottom, you didn't fix the 2 errors. And you called them in the client class.
Oh, I need to change the lowercase letters to uppercase letters. So I need to jump down to where I use the fraction class. And since our fields, numerator and denominator, have capital N and capital D, I need to change that down here. So I'm going to go down to main to where I use the fraction class, and we're going to use f1.numerator, capital N is equal to 1, f1.denominator, capital N is equal to 3, and I seem to have made a spelling error. I haven't rebuilt it or something because it's underlining it. Okay. Now instead of doing double R is equal to f1.calculate, I'm going to comment that line out. And I'm going to change my write line statement here. I'm going to write out f1.capital V value. And that invokes the getter on the value field, which does the division of the numerator and the denominator. And the thing to note about that is that there is actually no variable associated with that getter, right? We did not go in and create an instance variable in the fraction class called value. We just added a method. That's all that this stuff really is declaring a method called height get and height set there. Or for our fraction, numerator get, numerator set, denominator get, denominator set. And what those do is they manipulate the private variables, numerator and denominator, with the lowercase d's. And value doesn't even have an instance variable that it manipulates. Instead, it just calculates a value and returns it. Hope that makes sense. Read the chapter carefully, especially you Java folks. Alrighty, it'll be about time to wrap this up. So the convention in the textbook is for your private data to have a lowercase I, and then when you make a public field that exposes its values or whatever, then you put an uppercase I, uppercase letters, which I did on one of my examples on the fraction class, but I didn't do when I was starting the rectangle class. That's a good place to stop. So let's stop there. Go ahead and upload to the Dropbox. I'm going to go ahead and, well, the homework over classes is already posted, so you can start on it whenever you want. But we're certainly going to do at least one more lecture on this chapter. Absolutely.
I don't know if I'm in love with the way they do the methods.
Yeah, so you're not digging that?
I mean, I don't hate it. It's just different.
It is.
It's like, wait, what?
Yeah.
They what?
It is different than how you did it in C++ and how you do in Java. So yeah, it is significant.
I'm probably going to have to comment every single time. This is the
right. This is the getter. Right.
The method.
Right. But the reward for that is that you can access it just like this, f1.numerator. You don't have to do f1.setNumerator.
Yeah.
And or f1.getDenominator. So it is cool.